Hello, students. For this activity, we are going to practice some methods for making solutions of a predetermined molarity. So let's go ahead and look at our materials and then our procedures. Okay, for this part of the activity, our goal is to make 50.00 milliliters of 0.200 molar viridis, which is going to be the compound that I'm going to use for this demonstration. It's a green dye. Okay, when I wrote these numbers on the whiteboard, something should have stood out. It says not 50 milliliters, but 50.00 milliliters. Remember that in making solutions, we strive for two things. One of them is accuracy. How close is my measurement to the value that I'm trying to reach? The second one is precision. How confident am I that if I repeat the same measurement again, it'll be within a very small percent of variation? We typically indicate precision by the number of significant figures or significant digits that we put in the number. And so 50.00 milliliters means that if I were to measure this, I'm confident that my measurement is only going to vary in that hundredths of milliliters range. Now, notice, here is a standard 100 milliliter beaker. Notice that it has volume markings on the side, 20, 40, 60, etc. Now, let's say I want to measure 50 milliliters here. Well, I'm going to look for that line right between the 40 and the 60. Notice that it's very approximate. If I fill up liquid up to that line, I might have 47, I might have 52 milliliters. I'm not exactly sure of what the level of accuracy is here because the instrument is not designed to give me a high precision measurement. Now compare that with, for example, a graduate cylinder. This is a 100 milliliter graduate cylinder like we've learned before. Again, it has intervals in there. This instrument, you can measure 50 milliliters in it, and you know that it's going to give you a precision of 1 decimal. Remember that if these increments are in 1 milliliter, the rule is we add one more digit, in this case a decimal, to our reported measurement. But notice that this is not going to work for us because we're looking for 2 decimals. In other words, we want precision to the hundredths of milliliters. For these types of measurements, we use other types of equipment. For example, we use what is called a graduated pipette, and I'll show you how it works later on. And we use a volumetric flask. The volumetric flask is a bulb-shaped flask, and I don't know if you can see it, but over here there's a line. Let me move this around. You can see there's a line there. And this is designed so that if I fill liquid there and the meniscus is sitting on that line, this instrument will have a precision of exactly 50 milliliters. That is 50.00 milliliters. In this experiment, you are going to make, as I said, a solution that will be 0.200 molar in this compound, which I'm calling the viridis dye. I made it up, okay? The solution that we start with is 2.0 molar. However, our final task is to make that solution 0.200 molar. So we need to calculate, first of all, what we need. Let's go back to the whiteboard. Remember the dilution formula. M1 V1 equals M2 V2, where this represents my initial conditions, my initial solution, and this is my final solution. So let's see who is who in here. I'm going to use a different color. I want to make a final solution that is 50.00 milliliters. So that would be V2. And I want it to be 0.200 molar in Viridis dye. So that's my final. That's M2. I was just told that my stock solution is 2.0 molar. I talked to the guy at the stockroom. He says, you know, you can call it 2.00. It's okay. Okay, so let's do 2.00. So that means that M1 is 2.00 molar. 2.00 molar. So that means that my unknown in this case is the volume of that standard solution that they gave me from the stockroom. So what I need to do is algebraically, whatever you pronounce it, sorry, solve for V1. Okay, so now what I'm going to do is I'm going to put in the numbers. Remember, my final molarity is 0.200. My final volume is 50.00 milliliters. And you might wonder, let me turn this a little bit here. Why am I not converting that to liters? Well, because I basically assume that I'm going to need milliliters here, so I can leave it expressed in the volume unit that I need. Divided by 2.00 molar. And when I calculate that, it comes up to be essentially this divided by 10, right? The molar units cancel out. And what I'm going to get here is 5. But be careful with significant figures. I have 4 significant figures in that volume, but I only have 3 in my final solution and 3 in the concentrated solution they gave me from the stockroom. So my final result has to be rounded to 3 significant figures, right? Okay, so that means that I am going to need 5.00 milliliters of my concentrated solution from the stockroom. And I'm going to have to dilute it to get to my 50.00 milliliters. Okay, so in order to make our 0.200 molar solution, what we're going to do is we are going to use a volumetric flask. Remember, it's a bulb-shaped flask with a line in the neck, which indicates a measurement of exactly 50.00 milliliters. Now, we just calculated that we needed 5.0 milliliters of our stock solution of the Viridis dye. Notice that it comes with a little dispenser pipette here on the side. But I need to measure exactly 5.00 milliliters. So what I'm going to use for that is I'm going to use my 10 milliliter graduate cylinder. Remember, because the small intervals in a 10 milliliter graduate cylinder are calibrated to be 1/10 of a milliliter, that means that I can use this to measure volumes to a precision of 2 decimal places. That's right. So let's see how we do that. Okay, normally when you are given solutions from the stockroom, they're going to be placed on a cart on the side of the lab. But for this demonstration, I brought the Viridis dye over here to the bench. And remember that it comes with a dispenser pipette or transfer pipette next to it. And as always, when you open it, remember first loosen it up. And then at the end, hold it between your little finger and the palm of your hand so you can take out what you need. So I'm gonna take some stuff here. As you can see, it is green. And I'm gonna use this to measure exactly 5 milliliters on my graduated cylinder. Okay, that did about half of it. So let's get some more. I want to make sure that I am at eye level so that I can see the meniscus arriving exactly at the 5 milliliter mark. And you can see that I overshot it there. So I'm just going to go in and take a little out of there. And I got to fix it a little bit, maybe one more drop. And I think one more drop. And there we are. Our meniscus is, I'm sorry, it's a little out of focus. Trust me, it's at the 5 milliliter mark. So I'm going to replace the dispenser pipette back onto the little test tube on the side. And I'm going to replace the cap of this. And I'm going to return my stock solution back to where it belongs. And now what I'm going to do is I'm going to take this and I'm going to carefully open the lid of this. Notice that it has a little flat top, so you can hold it again between your fingers and then very carefully pour in. Now, for a bigger one, sometimes you use a funnel, but most of our funnels are not thin enough to fit in here and they would probably break. So I'm going to very carefully pour this down there into my flask. Now, what do you notice now? You can see there's some residue in there. You know, water has very strong cohesive forces, and so it doesn't want to let go. So what I'm going to do now is, rather than pour water into the volumetric flask, I want to make sure that I get all this because I measured it to 2 decimal places of precision. I want to make sure I get all of it. So what I'm going to do is I'm going to bring out some of my water, and I'm going to use that to fill it up in a series of washes, okay? Okay, let me replace the cap on the volumetric flask because I want to make sure I don't drop it on the floor or something like that. What I'm going to do now is I'm going to use my wash bottle with distilled water, and I'm going to rinse it down the sides here. And I want to make sure that I get all of that. And you can tell from the greenish tint in here that there was some leftover Viridis solution. All right, I'm going to do that. And now I'm going to, again, open the cap of the volumetric flask, hold it between my fingers, and I'm going to pour down what I washed. So then be careful not to let any of it drip outside the flask. I'm going to replace the lid now, and I'm going to do another rinse of my graduate cylinder. Again, go down the sides. I'm trying to make sure that everything that I had measured in here is completely taken up and poured into my flask, right? So I'm going to open this again. I'm going to pour down the water. And at this point, everything that I had originally measured should be in there. You can tell that the color of the dye has diluted, right? So the rest of the way, I can simply squirt down with my distilled water bottle until the liquid gets to about where the bulb of the flask ends and meets the neck of the flask. So that's as far as I'm gonna go. Okay, up to about there. I wanna be careful that I don't overshoot it, right? So what I'm gonna do now is I am going to, again, replace the lid. Wait, let me make sure I get the water out of the way. I don't wanna get in the way. Okay, I'm gonna replace the lid of the flask. And now what I'm gonna do is I'm gonna add water using a dispenser pipette. So what I'm gonna do now is I'm gonna use my graduate cylinder. I'm gonna put some more distilled water in there, all right? And what I'm gonna do is I'm gonna use one of these transfer or dispensing pipettes. Sometimes they call them Pasteur pipettes. So again, I'm gonna take out the lid here, and I'm gonna get water from here, and I'm gonna add this very carefully. Remember, there is some down the sides here. I wanna wash it down, all right? And then very carefully, I'm gonna start adding. Now I can see that the line that I'm shooting for is right there. So over the next few moments, I'm going to use very carefully, I'm gonna try to push these droplets down. You know, if you see droplets on the sides, it probably means that the glass had not been acid washed, but that's okay. We are still gonna get the precision that we want. So what I'm gonna do now is I'm gonna add this dropwise, very carefully. Until my liquid is at the meniscus of the the meniscus of my liquid is right at that line. And at that point, I am going to replace the lid of the flask. And I'm gonna grab it, and now I can stir it to get it mixed. At this point, if everything was clean, it's okay to invert it a few times to get a good mix. And this should now be the test solution that I'm gonna be using for the second part of the experiment. Now, one thing that would come to mind is the following. Can I just mix 5.0 milliliters of my stock solution, the concentrated one, and just add 45.00 milliliters of water? 5 plus 45 equals 50. Is that right? No, it's not necessarily right. And the reason for that is that when you mix solutions, the molecules of solvent and solute have to accommodate. Pretty much the solute has to occupy spaces between the molecules of the solvent, which in this case would be the extra water. And as that happens, the volume of the solution might change. In other words, volumes of liquids are not necessarily additive. And that is a very important concept in all this, and the reason why we go through so much trouble doing these things. Now, as we'll see later, once the solution is more dilute, in other words, where the ratio of solute to solvent is very small, then it's probably going to be a moot question. It's probably not going to be as important. And at those levels, we may be able to assume that adding, let's say, 1 milliliter of this and 4 milliliters of waters will give you exactly 5 milliliters. But for this particular case, where we're starting with a concentrated stock solution, you cannot assume that volumes are going to be additive.